It's now my pleasure to announce Thomas Fischer, and he'll be talking about forensics on Windows, and especially with the built-in tools that come with Windows.
Yep.
Please give him a warm round of applause.
Thank you. Thank you. So, well, good afternoon, everybody. Hope you had a good lunch. You're not too tired. You're not going to fall asleep. Hopefully, I won't put you to sleep. I have the pleasure of always starting on these after lunch or before lunch. So I'm in like a zone where either people are trying to get out of the room to get to lunch, or people have come back from lunch and are like. So I'm Thomas. I've been attending and participating in DeepSec for quite a few years now. I think this is my fourth year. I really enjoy the conference. I really enjoy the people here in Vienna. So thank you for having me again. My background is actually wide and varied. I'm currently more of a security architect and security engineer. That's my current role activities. But I've been in teams where I've done incident response, I've done threat hunting and things like that. And one of my roles has been around forensics. Now, I don't particularly enjoy having to do things with built-in going out and finding new tools. Mostly because we already have a lot of the tools underhand, right? There's a tendency in our industry, and especially in InfoSec, to think, oh, we need to get the latest and the best tool. We need to find the latest and the best tool. And then we've got the vendors that come in and say, oh, look at my solution. It's really great. I'm going to sell you a new solution. It's going to find everything for you. But have you ever stopped to think that what you have in your hands, what you have already in your organization, might be able to do what you need to do? Some of these things are built in. Some of these things you don't need to deploy anything with. You just need to have the right set of skills to basically use them. So, stop and think. And a lot of my presentations nowadays are about that, about getting you to stop and think, oh, could I be doing this a different way? Could I be doing this a better way? Could I be doing this an easier way or a cheaper way? So, in my role as in incident response, and especially I do consulting, and some of my customers, mostly people that I know, call me in after an incident, and they're like sitting here going, oh, we've got a really major incident. We don't know where we're going with this. We don't know what we're doing. And we've got all of these things, all of these devices, and I have no idea which one to start with. You can't see it very well, but there's a little arrow pointing to a switch port there. It's like, where do we go from here, right? Because you found potentially one bad device or one bad endpoint, and you're like, ooh, what do I do next? So when you're faced with that thing, you're banging your head against the wall, right? I mean, how many of you have been in that kind of situation? Let's be honest. You've got an incident, you have no idea where it came from, you don't know what's the next step. Anybody feel that's kind of what they've run into a lot of times? So, you end up banging your head against the wall. So one of the things that I was thinking about doing this is like, what could I do to facilitate this process? Because one of the big problems is that we tend to not have tools at our disposition when we're facing these problems. A lot of times, I've also run into a situation where you're dealing with shadow IT. You've gone from maybe the endpoint that triggered the event, triggered the alert. There's a guy in the front row just like going, oh yeah, fuck man, that's really true. Oh, one thing, I apologize, but I tend to inject swear words every once in a while when I'm talking. It's just, I don't know why, just I do it. I'll try and behave. I hope you don't get offended. But so you're facing all of this shadow IT stuff, so there's absolutely no tooling. So all that investment that you made in that great vendor pitch and all that doesn't work. Because why? Because there's no bloody tooling. So you're stuck with machines that are potentially infected and you have no idea what you're doing. So I was working around this problem and I'm like, what are my criteria? I've got an architect. I've also got project management in my back history. So I'm like, so let's build a requirements document. I didn't really build a requirements document. I just put some checklists down. So I wanted it to be non-intrusive. So that means I didn't want to have to deploy anything. I didn't want to have to mess up the machines. Now, there's a school of thought where, if you're doing forensics, you shouldn't be touching or you shouldn't be deploying anything on the machine because you might end up messing up the image, blah, 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 this, depending on the train of thought, depending on who you talk to. The thing is, I just didn't want to, right? Because in one situation, we were facing potentially like 50 to 60 virtual images of Windows boxes. So I didn't want to have to deploy 50 things, right? I wanted it to be easy, quick and easy to use, or quick and easy to deploy, if I had to deploy. And I don't really want it to cost anything, because if I have to start buying tooling, that means I have to, licensing, I have to make maintenance, and blah, 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 and blah, 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 money, 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 money. And then the customer doesn't pay me because they're spending too much money on the... Never mind. So I also wanted to go beyond the forensics aspect, right? A lot of times when you're faced with this problem of going through images that you have no idea what's going on them, there's a part of an investigation that you need. There's a part of a hunt that you need to do, right? You need to go looking for things. You need to go find things, go find evidence. So the whole idea that I was having during this time is I was like, well, I could use this actually as a hunt tool. And if I find that hunt tool, then I can use my traditional forensics tooling, right? Capture the image, run it through SIFT from SANS or whatever other tools the customer might have or I might have under hand that I was bringing with me. So I'm sitting there thinking about this. These are primarily Windows boxes. They're pretty modern Windows boxes, Windows 7, Windows 10, Windows Server, latest version. I'm like, what's the common factor in here? PowerShell. For the past few years, Microsoft has been driving PowerShell as the system management solution and the new command line for Windows. And it's actually quite powerful, right? PowerShell in itself, at its base, supports regex. So you can actually do finds and you can query things. You can list directories and you can put regexes inside the query. So for example, if I do this string inside a variable, I can actually match the domain. Now the thing is, I can actually pull that string out of registry because PowerShell has access to the registry by the command line. You can actually change directory in PowerShell and go into the registry. That's pretty neat, right? Instead of having to open registry editor or dump the registry and parse it with something else. You can also get event logs, right? So you can get these event logs out as well. So if I'm looking for security event logs, I can pull the event logs into a PowerShell object and I can search for the ones I need. And the really cool thing is that everything in PowerShell, or the data, can be managed as an object. So if you're used to using Python and stuff like that, having an object is quite powerful because you can use key value pairs. Having key value pairs, you can start to actually process data in a very neat and convenient way. So this is really good. Yay. Problem. Most PowerShell, when you're using like this, you're going to write a script in a file. I'm going to have to dump the file on the disk. That doesn't work for me. I just want something that I don't have to deploy anything. I just want to be on the command line and I just want to, or have some way of just easily running a script. Right? So I don't really want to have to deploy anything into the disk. Hackers for the win. So a lot of you, if you worked in if you're working in incident response lately, if you look at a lot of the malware, a lot of the attacks that are happening lately, they do these kind of PowerShells and they download stuff from the internet, right? Or they download stuff from a network device. So I was thinking, wait a minute, I can use that, right? If I'm in an organization, I just put my scripts in a central file share and I can just download them and inject them straight into memory, instead of actually writing to disk. Because this command, it's hard to read, but the command will actually download the file as a memory object, as a variable, and run the variable. It won't actually write anything to disk. So everything's now in memory. So I haven't changed anything on the disk. Cool. Success, yes. I'm a success kid. No, I'm not. I can run into more problems. So we've got an awesome start, right? We can find things, we can go through the registry, we can go through the event log, we're not going to change anything, it runs in memory. generally available on Windows 7 and greater. Lots of cool, useful scripts out there. You can actually Google. There's plenty of people who've done scripts around forensics works, around incident response. With PowerShell, there's a great tool for, I think it's called Power Forensics, which actually does forensics work. Will actually give you forensics. So they've got they can get you the alternate data stream, they can download the event log, they can do prefetch, they can do recent file caches and things like that. The problem with Power Forensics is most of the logic is actually inside a DLL, so you have to deploy the DLL. So that's the reference for Power Forensics. It's a really good tool, don't get me wrong. I just didn't want to have to deploy another DLL. So that's one option, but I don't want to deploy the DLL. What do I do? So I start to go back to my problems of building something. So what I want, I've got PowerShell, right? I've got PowerShell. I can create scripts. I can access built-in objects. And if I'm smart, now I'm going to be able to do some forensics, and now I'm going to be able to do some hunting. That's where I want to get to. So let's go hunting, I said to myself. Let's start playing with this. So I'm looking for this thing, and I start reading some research from Yogesh. Oh, his name's on the next slide, I think. Yes, it is. Yogesh Katari. So he published a paper in March 2015 where he was looking at SRUM, so the System Resource Usage Monitor, to process forensics work. Basically, it provides you with information about processes and network-related matrix over time, right? So you've got a visualization of what's happening on the machine. And it's in most machines since Windows 8, and it's part of the Diagnostic Policy Service. So it's part of the system that basically captures information when you blue screen or when you get an error, and you get that window from Microsoft that says, do you want to send this information to Microsoft for further processing to do whatever they do with it. So he wrote this paper, the forensics implications of SRUM data in Windows 8. So what's SRUM exactly? So it's Windows 8 and above. So you've got Windows 8, Windows 10, Windows Server 2008 as well and above. It monitors desktops and Windows applications. It monitors services. It monitors network connections. And it's a historical database. It actually never gets cleaned. From the moment you install Windows, it's actually processing this data, and it's storing it. And it never really goes away. So that's interesting. So I've got a really historical data. The parts that it provides, so it's monitoring on by default, but it provides application resource usage. It provides Windows push notifications. So when you get those notifications on the sidebar or whatever, so it captures that. It captures energy usage. I was like, that's interesting. Network connectivity and network data usage. There are some constraints to what it captures, but it's quite interesting. So the positive side on the network is that it captures which interfaces you're using, which network profiles you're using, which byte uploads, and how many bytes are uploaded and downloaded, and which process ID SID is consuming all this information. But it doesn't have endpoint IP addresses, doesn't have ports, and doesn't have specific network activity. So you won't get like a net stat out of it. You won't get the connections that have been made. You just get the volume of traffic. That's still very interesting, especially if you have to deal with data loss. Because if you can track which process uploaded a ton load of data to the internet, well, just uploaded a ton load of data, you get an interesting viewpoint. For the application, you get a lot of information on how the applications, remember this is a performance thing, so it's about the application performance. So you've got CPU cycles, you've got context switches, IOs, number of read and write operations, number of flushes, which user was running it, which user SID was involved, who launched it. That's a really good one, actually. So my thought process around that one is, wait a minute, if I can track which user ran the application, then I can look at a user and say, did you run this application? If they say no, I can say, well, your user ID ran the application. Yeah, that's not really exactly good proof, but sometimes you get users tell you, oh, I didn't really run that application. I never clicked on that thing. Maybe you did. But it doesn't provide memory information. It doesn't provide anything about the kernel info. It doesn't provide cache, all the typical things that you would look for if you were doing memory forensics. It just provides you a snapshot of how the application was performing and what it was using in terms of system usage. You have application history is actually viewable in Windows 10. So the interesting thing is that if you go into Windows 10 in the task manager, you have this show history for all processes. So when you click on that, it'll actually show up. You get a list of all of the usage of all processes, but you also get a history of processes. So through this, you can actually get which processes have been run but are no longer on disk. So that's interesting, right? So a process that's run but no longer on disk would indicate some kind of forensics cover measures, right? So how does it work? Basically, you've got a bunch of DLLs that represent the information you're looking for. Come on. So you've got like Windows Network Data Usage Manager. This points to GUID, which is actually pointing to a DLL. That's registered in the registry. The registry starts to, well, the system starts to capture the data, temporarily puts it in the registry. It then writes it out to disk. And this happens every 60 minutes. So there's two phases to this. There's registry, commit to disk. You know, it's like a caching system. I mean, if you've done any development and you've done any development high capacity or real-time type stuff, you probably know what this is. This is an example of the extension registry and some of the information that's available to you to kind of understand which DLL is generating this data. So the database is ESE, so Extended Storage Engine. What's interesting is this database is actually also used as the database for the Internet Explorer cache. I'm not sure if it's the same thing for Edge. It also is used by AD, it's used by Windows Search, Windows Update. The System Resource Usage Manager one is in a system folder under SRU, and it has a bunch of tables like any good database does, right? So you've got database for network connectivity data, application resource data, network usage data, Win push notification data, energy usage. So a typical database, right? The network usage database has columns, of course, right? It's a database. So we can see what kind of information we have inside the database. So we've got an application ID, a user ID. So we know which application and which user was using the interface. Was using the network. We have an interface LUID, so we can understand which interface was being used. And we have network profiles and the bytes sent and bytes received. The interface information is actually quite interesting because if somebody's using it with VPN, that shows up as a different interface, right? In the way Windows works. You have to know a little bit about how Windows works to fully understand this data. So the profile, some things you have to decrypt some of the information you have to pull from registry because it points back to registry, and some of it there's actually a DBI, there's actually a reference database inside SRUM which allows you to pull out the information. What's interesting and what's annoying is whoever wrote this, or whichever teams wrote this, can't decide on which format the date has to be. Is it early automation date, or is it floating time, or is it application time? And wait, I'm going to show you something even weirder later. You've got the application resource usage. So, same thing again. We've got the app ID and the user ID. We've got the date problem, and you've got all the information regarding how much CPU, time, etc. was used by the application. This is the most interesting part of the database. So this table tracks every process, every service, every subservice, and every user ID that ever does something on the machine. It's basically an index referential so that they don't have to put all this information in the other tables. They've optimized the SQL database, right? Except it's not SQL, and we'll find that out later. So you've got an ID index, and an ID type, and a blob. The blob is basically your information. This is where it gets a bit annoying. Because it's just a large binary data blob, what Microsoft did is they decided that the ID type was going to describe the type of data that was formatted inside the blob. right? So basically, if you have ID type 0, you have an application path. It's a UTF-16 encoded string, and it points, which is what's in the blob. If you have ID 3, you have a SID, but it's a binary piece of information. So that means you have to take the binary piece of information and convert it back into ASCII SID if you want to understand which user SID you're actually dealing with. They could not make this more annoying, right? So you've got SIDs galore, so you have to decrypt the SIDs. I already talked about the UTC timestamp format or the OLE format. It's actually quite similar, but it's just really annoying to have to think about dealing with two different separate timestamps. The network interface LUID ID is actually documented in the development stuff for networking. So basically, it's just the LUID has an index and an interface type, and so you have to decompile that to kind of identify which interface you're dealing with, and it's a whole bunch of mathematical stuff, and I hate maths. So I Googled and I found some people who've done it before and just like tried to figure out how to do that. So what's the forensics angle of this? So the forensics angle is you've got a user map, right? Who launched what and when. So you can potentially see if a known user launched something bad, or if an unknown user started to launch something good because of the way the SIDs work. You've got network statistics, where and how much network activity per process. You can track programs, find those that were deleted but ran. And you've got process runtimes, so who was up the longest, who was playing the longest with the system. And I was thinking, well, hold on a second. If we can see all of the processes, applications, and we can see how much CPU and stuff like that they're using, I could potentially track network miners with this, right? Because at the end of the day, they're going to be using a lot of CPU and a lot of energy. I still haven't gotten to that one, just haven't had time. And I also have to find a machine where Strum is active and we've got a network miner. So what do I mean by this process running time? So if you do forensics, one of the things you try to do is get the prefetch to understand which applications were run. The problem with prefetch is it only generates at start of an application, right? And it only lasts for about, I think it's 8 hours or 6 hours, something like that. So the prefetch only tracks the application 6 hours. Shrum, on the other hand, so if you have prefetch, this is basically what you know about the application, this purple line. Shrum, on the other hand, does periodic checks. So it periodically looks at what the usage of the application is. So you can actually backtrack how long the application has actually been running because you've seen the usage of that application over time. So you're adding a lot more visibility. So you can actually tell, did it run? Did it do something? And you can start to look at the time frames of when it's actually doing something and not stagnant, because it's going to use CPU cycles and things like that, and context switches. It's a much more complicated problem. I haven't gone to that either, because it's just that requires a lot of graphing of the data and decompiling of the data. And I'll show you. I keep running into problems every time I take this data apart. Some other useful trackables is we can map processes to users, which is useful. We can map processes to network activity, so we'll see which processes were doing networks. So for example, if you see calculator has a network activity, you're probably something wrong on that system, right? That's what you'd be looking for. And just general program usage investigation. Who's spending more time on the internet? That's not allowed. Problems. ShrumDB is locked. It's a system resource. It's used by the system. It's always open. You need to use libESDB for ESS to CSV conversion. That's one tool that's available to you. It's open source to be able to dump that data and convert it to CSV. Mark Baggett has a Python and an executable that generates a CSV. It extracts the data and generates a CSV, which you can then use in Excel. Problem is, if you're going to use it, you need to either deploy as executable or use Python. Again, if you go back to my requirements, is I didn't want to have to deploy anything or deploy any executables. I wanted to use the built-in tools. So, problems. And the other problem I have too is all I want is a copy of the DB that doesn't require me to do an image of the database, right? Because these tools would require me to do an image of the disk or require me to take the system offline. So I didn't want that. So I was like back to my head banging. Oops, sorry. Did I? No, it's okay. My hand just hit the. So I'm back to my little problems and my headaches. recording, it's not useful. So, but wait a minute. Are we good? Yeah. So I'm like, wait a minute, but I still have a solution for this, right? There must be a solution for it. And I found one. Basically, PowerShell really does cool things. Remember I said that at the beginning? You can actually load .NET libraries into PowerShell. And you can do .NET type queries, or you can use .NET in your scripts. And all you have to do is add type, path, and the path to the library. So I'm like, this is interesting. Now, I know there's a library somewhere that accesses this databases because it's being used by applications and the system. So I do some more Googling. You've got to have Google Foo when you're doing this stuff nowadays because somebody's done it before, right? So I found one. There's actually a .NET API for ESE, so to access ESE databases. It's in .NET since version 4. It's called ISAM ESNet Interop, and it's in system, Windows, Microsoft.NET, Assembly, really long path. But the thing is, I have yet to find one system where this library isn't deployed. Because as soon as you start to put a lot of the UI components of Windows, that library gets deployed because so many applications rely on .NET. So this is really interesting, right? So I have my command, and I'm back to success. Yes, I can access the database. So started to script it, right? This is where I'm going to take a walk through, and not having the mic in my hand is going to be very difficult. So we'll take a route through and do some demoing. Let me just, where'd my window go? Oh no. Hold on a second, I messed up. Actually, this will work. Right. Okay, is the text okay for people at the back? Can you guys read that at the back? Yeah? Or you need it a bit bigger? We good at the back? Text size? Good. So first thing is, I'm going to set up a variable where I'm basically just putting the path to the library. So this is where this is where power of PowerShell is I can actually reference environment variables like this, right? So $envir is actually a variable which allows me to see the standard environment variables. This is the path to my database. So I add the first thing you would do would be to add the DLL into memory. So now I can start playing around. So I won't go into the technicalities of accessing a database, but essentially ESE is jet database, so you have all these bunch of jet database commands, which are really annoying in my point of view, because it's not a database, it's like a flat file with lots of different weird constraints. You have to because you don't know the file type nor the page size, you essentially have to build the file type. You have to set it to 1 for it to go get it, to go fetch it. Then, can I do word wrap? Nope. So then you have to go get the page file size. So here I'm accessing the database, asking for the page file size. I'm accessing the file type to get the file type. The file type will actually return a code that if you pass it into this jet function, you get the DB type. And the DB type will say database. Yay! Right? So then you have to open a session to the database. So we've got all this stuff. So I'm creating a new object, jet instance, jet session ID. This is like writing .NET stuff, right? Like writing C. Then I have to specify page size, recovery, circular logging. It is all you have to do all of this to open the database. It's incredibly annoying. So then I create an instance, then I init, and then I begin a session. Okay, we have a session. Do we have access to the data? No. I now have to go and open the database. Seems logical, right? So I open the database. Same thing again, some really fancy .NET paths. Basically, if you've never dealt with .NET, essentially, these are paths to the functions in .NET. So you're basically saying, please load library Microsoft ISAM, ESNet, interop, and access function attached database gribbit. Okay? So that's what all of these little funny things mean. So once I have a session, I create an attached database first, then I can open the database. Once I open the database, I have an database ID. You'll notice that my open database doesn't actually return my database ID, it returns an error status. The database ID gets set inside the function itself, right? So you got to be careful. So you got to, this reference basically means use a reference to the database ID so that you are able to use the shared memory and you can return the value. Are we finished yet? Can we get the data now? No, of course not. So then you have to get the table names. And this is where we're fun. You'd expect something logical, right? No, it's a GUID. So you have to come back and find out which GUIDs represent which tables. And you're like, so this got to be documented somewhere. Yeah. No. So, but again, the guy who originally wrote this paper, he actually started to take this apart. You can actually figure out which databases by looking at the tables. So I'm going down. Then I go into the problem is Windows 8 has 7 tables, Windows 10 has 10 tables, Windows 10 now has 15 tables. It's like, what? This is a fun job, I'm telling you. Right, so then you can actually access the tables, you can get the column names, you can start getting the data. I think, oh, this is easy, it's a database, right? I'm going to be able to do something like select star from table. No. You have to get the column names, then you have to access the row, then you have to ask for the data for the column for that row. So you're basically asking for each piece of data for each row and then for each subsequent row. So to get one line, you basically have to do something like this because you have to figure out what data it is and things like that. That's in the column information and et cetera, et cetera, et cetera. So I got really annoyed. So I scripted everything because you're not going to do this once. So let's do the demo. So I might have to put down the microphone to do this. So I basically scripted this whole thing. For PowerShell, it's really nice because it does auto completion, things like that, so I don't have to remember the commands because you have to deal with a lot of things. So now I've connected to the database. So this gives me the following information that we saw in the script. So you see I've got a state, I've got an instance, I've got a session ID, I've got a database ID, etc., etc. So next I need to open this from the database. So I'm going to so I'm going to get the table names. So my scripts are a little bit painful because I've been doing these at night, in the middle of the night. So I'm going to get the table names, I pass it a session and database ID, right? So now I have my table names. So you see this, this is the object format that I was talking about for PowerShell. Basically I build an object where I've kept status IDs and things like that so I know that the data came back okay. So to access that, the actual table names, I can do table names dot tables. I'm going to format it as a table, pass the format. Now I can see my tables. So you see that we have the Shrum DB ID. table down here, and then we have all these GUIs over here, right? So a little bit. So we're getting somewhere, right? Yay. So then I can actually open a table, right? So current table. I can open Shram table, open Shram table. Okay, you know what? I'm just going to copy the line from above. Make it quicker. This is why I use an IDE when I'm doing stuff like this. So now I've opened the table. You see my open status table is okay. So if I look at the current table, so I have open table and I have a table pointer. I can now get the rows. So I'm going to put the rows in a variable because I know there's a lot of data. Now you see it took a little bit of time, right? On my home system, which has been running for years, it takes like up to 15 minutes. I was like, at first I thought the script wasn't running properly and I had bugs, so I kept breaking it. And it's only until I had to walk away and go feed the cats or something, and I ended up, it actually pull out data. And this is what the problem is, that now I have all this data like this, right? And the data, and it's like that. Yep, it is. Yeah. So again, now I'm going to get the reference ID because there's one more thing I'd like to show you. Shram reference DB map. So this one I've actually started to make it a little bit more complete, where I'm actually doing some processing on it, mostly because this is one of the more important tables, and until I finish processing this table, all the rest of the data is going to be useless. So if I look at DBID, put the right freaking command, it might be useful. Okay, so see, it's a little bit nicer now because I've got a progress bar and everything, so we're starting to get somewhere. I just don't have time to work on this, to be honest. I've come out with a status. I print out a status so you can capture the status as well. You can actually put that status in a variable. I could do $dbid, $status, and it would be put into variable. You can put multiple assignments in PowerShell, which is nice. So if I do dbid, so now I've got an ID and the blob. So the blank blobs are probably GUIs or no information, which is really annoying. But let's go up here. Oh, come on, I know. There we go. So these are programs, right? I'll take this back. These are programs that run by Microsoft. Now, it's supposed to be, from what I understand, the program name, the date launched or something like that, or the first view, or the date it was created, and the version number. But apparently, some programs run in the future. Okay? So I've got 2052 for a side client, search filter 2084. Like, when I saw that, I was like, what the hell is going on here? So more investigations need to be done. Right? That's basically where I was going with that. What happened to my presentation? Help. So, walk through, demo, we'll skip, demo, this was the demo, same thing, we just went through all of this. So, these are the current scripts that work, that I have, they're published in GitHub. So I've got one that connects to the database, I've got a closed database, I'm starting to dump the DBID map, I can grab rows, I can grab table names, If you need column names, like there's a couple of ways of doing it already. So what's the good? So I can automate data processing, right? I've got better extraction of GUIDs. I need to pull registry entries though. Using PowerShell remotely is my next step, because sometimes I don't want to go to the machine, or it's just easier if I could script a whole remote session. I want to build a complete module so you can just load one PSM instead of loading a bunch of PS files. Problems that I have is you need privilege escalation because you need admin if you don't have admin rights. Push PowerShell version implications, Windows servers, where is SHRUM? On Windows servers, it's not in the same place. God, Microsoft, you make my life so nice, and never mind. And then I did this presentation, a version of this presentation at Securite. Very good conference if you're a student and things like that. And about half a day later, students got nothing to do else on their time except take apart my stuff. And he says, oh, it's not working. I'm like, okay, let me figure this out. It's like, fucking GDPR. Because this stuff gets sent to Microsoft, they had to stop using it in Europe. So there's a restriction on its use, so it's no longer enabled by default on certain versions of the OS. I was like, no! Luckily, you can actually re-enable it. There's a documentation on Microsoft's website to re-enable it. So where am I with this, right? If you go back to my requirements, so I can track application usage, I can track network. So I can start doing a little bit of hunting for user activity and stuff like that. Whoops, there's supposed to be a build on that. So I was like, well, how do I do hunting? Well, remember, PowerShell very powerful. This first line up here takes a list of file hash, creates a list of file hashes for all the binaries on the system. That could be useful. This one actually will go find a hash. This one, the bottom one, will find all the USBs that have been plugged into the machine. So quite useful. So I'm getting somewhere with this, right? So I've got find files, find hashes, I've added. I've got system, searching for events, configurations. I recently found out Sigma actually converts to PowerShell. So I could use Florian Ross rules and actually go looking for stuff for using PowerShell. So I've got a MIDI hunting tool, right? Almost an EDR tool, almost like an OS query thing. So I was like, this is actually pretty useful at the end of the day, right? I've got something that I can take a little bit further, borrowing some plain, simple programming and taking time to actually finish it. So thank you very much for your time. I hope I made you think differently, hopefully. Gave you some ideas, gave you some food for thought, on top of the food on top of the actual food. I think we have probably a minute for questions or something like that. Any questions? The back.
I'll bring your microphone, if my microphone is up. Yes.
Thank you very much. Awesome talk. Why did you not choose Sysmon logs and PowerShell logs instead of
So Sysmon's good if it's pre-deployed, right? So these are systems that had nothing on them, but we need to go look for things inside. So Sysmon, I love Sysmon too, right? Sysmon gives you a lot of good information. For the PowerShell Windows, for the PowerShell command line logging though, you're better off just turning on full logging of PowerShell on the newer versions of PowerShell, because that will give you, that'll actually, the thing with Sysmon, it captures the command line, but it doesn't actually decrypt any obfuscated PowerShell. If you turn on extended logging of PowerShell, the PowerShell logger will actually log the de-obfuscated command line, which is more interesting. But it requires pre-configuration. And really what I was doing with this is looking at machines that have been owned that had nothing on them, that were managed by, you know, some marketing department or some developers, whatever, and they needed to be taken apart. That's all. That was the reason. Anybody else?
One last question.
No, doesn't look like it.
Well then.
Thank you very much,
Thanks so
everybody,
much,
for your
Thomas
time.
Fischer.